Okay, so this is the continuation of section 3.4. This is question number 16. Let's start out by reading. A farmer wishes to enclose a rectangular region bordering a barn with fencing as shown in the diagram. Suppose that X represents the length of each of the three parallel pieces of fencing. The wording here I think is slightly confusing. When it says three parallel pieces, it's not talking about the three slats of one piece of fence. It's literally talking about this is one piece, this is my second piece, and this is my third piece of parallel fencing. Continuing on, she has 600 feet of fencing available to her. Part A, what is the length of the remaining piece of fencing in terms of X? In other words, we won't know what the actual number is yet. We just want to find out what it is in terms of X. So if I take a look here, I know that I have 600 total feet of fencing. I've already talked about three pieces of fencing, each X units long or X feet long. So I now have an X plus an X plus an X. These are my three parallel pieces. But then I also have that fourth piece of fence, the one down here that's parallel to the barn. I don't know how long that one is. That's what part A is asking me to find. How long is that? Now I could have used a variable. I just chose to use a question mark for the moment. If I would add those three x's together, that's exactly what I would get, 3x. And then if I subtract those three x's from both sides, I'll have that 600, the total amount, minus 3x, the three parallel pieces, gives me my question mark or my fourth piece of fencing. So 600 minus 3x, that's the remaining piece of fencing in terms of X. So this right here is part A. Part B talks about the area. It says determine a function A that represents the total area of the enclosed region. Give any restrictions on X. So I know that area we just talked about is base times height or length times width. We talked about that in question number 10. So length times width. We just found that the length of my rectangle is 600 minus 3x. And the width was what we had already talked about, which was a distance of x. So if I wanted to clean this up a little bit, I would have, by distribution, 600x minus 3x squared. Of course, we're not really familiar with writing it that way. We typically like to write our x squared term first. So I'm going to turn those around and say negative 3x squared plus 600x. So that is my function that shows the area. Now part C says what dimensions for the total enclosed region would give an area of 22,500 square feet. Determine the answer analytically. Remember, that just means don't graph on the graphing calculator. So this is going to be part C. We know that our area, our A, is going to get replaced by 22,500. And this is going to equal negative 3x squared plus 600x. This is just a quadratic equation. We have four methods of solving quadratics, as we've already learned. We could solve by factoring. We could solve by completing the square root property, or quadratic formula. I could choose completing the square, but I'm going to let you in on a secret. That negative 3 out front tells me I don't really want to choose completing the square. Not with the 3 out there anyway. It makes it a little bit uglier. It also means I'm not going to use the square root method because that's for only one variable. I could use the quadratic formula, but oh my goodness, the b squared, having to square that 600 and deal with a really large number, that doesn't sound very appealing to me either. So I think the first thing I'm going to do is a little bit of factoring. I do notice as I look at this that all three terms are divisible by 3. So I'm going to take and I'm going to divide on both sides by my GCF, which I'm going to use a negative 3 here so that my x squared will become positive, and it'll make my life just a little bit easier. So if I take the 22,500 and divide by a negative 3, that'll give me a negative 7,500. If I take the negative 3x squared and divide by negative 3, that's going to give me a plain old positive x squared. And if I take the 600x and divide by -3, that'll give me a -200x. At least those numbers are a little bit more manageable to work with. I'm going to get a 0 on one side, so 0 is equal to x squared minus 200x plus 7,500. And then I can make a little bit better judgment call on whether or not I would like to use factoring or quadratic formula. And even here, the completing the square would not be that bad now that my a is a value of 1. But still, I don't want to think about squaring that b term. That is not appealing to me. So I'm going to go ahead and factoring, which is my personal favorite method anyway. You choose what you want to use. So I know the x squared is going to be an x and an x. I've already done the math on this. I've cheated a little bit and worked ahead. So 7,500 is going to be a 50 times a 150. They have to add or subtract to get that -200 in the middle, so they're both going to be negative. And now I can solve by factoring by saying that either x is equal to 50 or x is equal to 150. Now, remember that part C said what dimensions. So I'm actually being asked for what are the dimensions of my rectangular yard. I actually have two choices here. So choice number 1, let me redraw the yard. Choice number 1 says that my 3 parallel sections of fencing could be 50 units. If I use 50, 50, and 50, that leaves, since I had a total of 600 feet, that leaves me with 450 units here. So one option for her dimensions of her fence are going to be either a 50-foot by a 450-foot total enclosed region. And then option number 2 is that I could use the second one, which was the 150. And if those 3 pieces are each 150, that only leaves me with 50 units here. So that would be a 150-foot yard by a 50-foot yard. Which one is more realistic? Quite frankly, I don't know. I'm not a farmer. I'd have a hard time believing, though, that a barn was actually 450 feet wide. And notice that our barn is the same width as our fence is. So if I had to guess, I would say that the more likely option was the 150 by the 50 foot. But again, I'm not a farmer and I've never actually measured a barn. So take it or leave it. Those are the 2 possible answers for the dimensions of this farmer's yard. See you in class.